These are notes on percent yield, which is chapter 12.3 in your book. And I think most of you are going to find this concept to be pretty obvious and to make a lot of sense. The challenge is there's a lot of information that we've learned in the past few days, in the past few weeks, and you kind of have to put it all together. So while this piece might be easy, getting there for some of you is still going to be a little bit of a challenge. So in order to calculate percent yield, you need two quantities, one of which is called the actual yield, and the other is called the theoretical yield. So the theoretical yield is the calculated amount of product based on stoichiometry. So when I give you a problem that says you have 30 grams of whatever reactant, how many grams of the product are you going to be able to make, and you calculate that out, that's the theoretical yield. The actual yield is the actual amount of product which you need to determine experimentally each time you do the experiment. So different people doing the same experiment with the same starting materials may all have different actual yields. And actual yield can be the same as your theoretical yield, but is more often less than your theoretical yield. So this could be because you spill a little of either your reactant before you start the experiment, or maybe you spill a little of your product before you make it to the balance. Maybe the reactants don't react completely for any number of reasons. Maybe there are some side reactions you didn't anticipate and maybe can't even see. Maybe something reacted with the air as the reaction was progressing. All of those could affect your actual yield by making it smaller than what you calculate it to be. And you can think of this relationship almost the way you think of a relationship between your test scores. The theoretical yield would be the maximum amount you could get on a test, say 40 points. The actual yield is what you actually get on the test, maybe 35 points, for any number of reasons. Maybe you left one blank. That would be like some of your reactant didn't react all the way. Maybe you got some wrong. And just like in reactions, with tests, it's likely that your test score is going to be less than the theoretical yield. Certainly not impossible. People get hundreds. But more than likely, there's going to be something that's going to bring down that actual. The same is true for reactions. More than likely, there's going to be something just in the environment around you or in what you actually do that's going to make your actual less than your theoretical. So then you calculate what's called a percent yield to see what percent of the theoretical you actually got. So before you continue the video, I want you to think about how on your test you calculate the percent grade, we could call it, of what you actually got. So, let's go back and say you get 35 points out of 40. 35 is your actual, 40 is your theoretical. How do you calculate the percent? So pause it, think about that, shouldn't take long, and then go back to the video. You would calculate your percent by doing 35 divided by 40 times 100. The same is true for percent yield. It's actual yield divided by theoretical yield times 100%. Pretty basic. So let's look at a percent yield example. So let's take this example. In a reaction between 2.53 grams of aqueous sodium chloride and excess aqueous silver nitrate, a student obtains 5.82 grams of silver chloride. What is the percent yield of silver chloride? So the only word that may be a little new to people at this point is the word excess. So what excess means is more than enough. So what we're really saying in this example is that the sodium chloride, the 2.53 grams, that's going to be our limiting reagent. And we have enough silver nitrate to react all of that sodium chloride. So see if you can figure this out. You actually have all the tools to figure this out. So my encouragement to you is to pause the video, see if you can figure it out, get the percent yield, and then check your answer. The first step is going to be to calculate the theoretical yield. We know what the actual is. It's this right here, the 5.82 grams. But we need to calculate the theoretical yield. So of course the first thing we do is we write a balanced equation where sodium chloride, which is aqueous, reacts with aqueous silver nitrate to yield solid silver chloride plus aqueous sodium nitrate. And notice that this equation is just balanced the way it is, mostly because everything either has a 1 plus or 1 minus charge, and so it's actually a pretty easy equation to go through. So then we do the stoichiometry. We need to do our grams of sodium chloride to grams of silver chloride. So that goes grams of sodium chloride to moles of sodium chloride to moles of silver chloride to grams of silver chloride, which gives us 6.20 grams of silver chloride. That is then our theoretical yield. That's what we should be getting if all the sodium chloride reacts and nothing happens. Step 2 is to then calculate the percent yield. So we've got 5.82 grams of silver chloride from the reaction. We should have had 6.20 grams, that's our theoretical. Multiply, so we divide the 5.82 divided by 6.20 times 100% equals 93.9%. So not bad. I'm sure a lot of you, if you got a 93.9% on a test, would be more than happy. Some of you are going to ask where the unit grams of silver chloride goes. Notice, because we're dividing grams of silver chloride divided by grams of silver chloride, anything divided by itself is 1, and so that cancels out. And that's why our unit is just the percent. Please feel free to add any questions you have on the comment section of YouTube. Have a good night.